16代目のクラウン、日本の歴史に重ね合わせれば、それは明治維新です。ご覧ください。新しい時代の幕開けです。
Prepare to witness an automotive revolution that could send shockwaves through the electric vehicle industry. Toyota's CEO has unveiled a game-changing engine that threatens to disrupt the EV dominance. As the world races toward electrification, could this innovation derail the EV revolution? Are we on the brink of a seismic shift in the automotive landscape, or is this just another bold claim in the competitive world of car manufacturing? Let's explore. The evolution of Toyota's engine technology. As Toyota stands on the precipice of a new era in automotive technology, its journey is nothing short of remarkable. From humble beginnings to the cusp of revolutionizing the industry, Toyota's evolution in engine technology is a testament to innovation, perseverance, and foresight. In the earliest days, Toyota's foray into engine development was characterized by engines that were simple, yet effective for the times. But did you know that during World War II, Toyota primarily manufactured standard-sized trucks almost exclusively for the Army? This period was crucial for Toyota, laying the foundation for its future in automotive engineering. Post-war, Toyota began to diversify and refine its engine technology. The company's venture into gasoline engines marked the beginning of a journey toward more complex and efficient designs. In the 1950s and 1960s, Toyota introduced engines like the R series, which were notable for their durability and reliability. These engines powered some of Toyota's earliest successful cars, setting a standard for the brand's commitment to quality. Fast forward to the 1990s and early 2000s, a period marked by significant advancements. Toyota introduced the 7AFE lean burn engine, a pioneering effort in reducing emissions. The development of the variable valve timing intelligent mechanism in engines like the 2JZGE represented a significant leap in fuel efficiency and performance. The turn of the millennium saw Toyota delve into hybrid technology with the development of the 1NZFXE, the world's first engine for gasoline-electric hybrid vehicles. These innovations underscored Toyota's commitment to environmental sustainability long before it became a global trend. In the past decade, Toyota has not only continued this legacy, but has significantly accelerated it. The introduction of the dynamic force engine family brought engines that delivered exceptional fuel efficiency without compromising performance. This engine family, powering models like the Corolla and Camry, showcases Toyota's ability to combine fuel efficiency with performance, a feat not easily achieved in the automotive world. But what about the present? As we stand in 2024, Toyota is on the verge of a breakthrough that could redefine the automotive landscape. The company's latest endeavors in hydrogen-powered internal combustion engines and the development of water-powered engines represent a bold departure from conventional automotive powertrains. These technologies are radical reimaginings of what powers our vehicles. Think about it. An engine that emits only water vapor, harnessing the most abundant element in the universe, hydrogen. The implications are staggering. This isn't just about reducing emissions or improving efficiency, it's about completely rethinking how vehicles impact our planet. And the mystery that surrounds these new technologies only adds to their allure. How will these engines perform in real-world conditions? What will it be like to drive a car powered by water? The answers to these questions could very well change our entire understanding of what it means to drive. As we anticipate Toyota's next big reveal, one thing is certain. The automotive industry is on the brink of a revolution, and Toyota is leading the charge. Toyota's hydrogen-powered internal combustion engines. In a world where electric vehicles are increasingly becoming the norm, Toyota's foray into hydrogen-powered internal combustion engines emerges as a game-changer. But what exactly sets this technology apart from the traditional gasoline engines and electric vehicles we've become accustomed to? The crux of Toyota's innovation lies in the use of hydrogen as a fuel for combustion engines. But why hydrogen? And how does it work in an internal combustion engine? Unlike hydrogen fuel cell electric vehicles like the Toyota Mirai, which generate electricity through a chemical reaction, HYSEs burn hydrogen directly in a manner akin to gasoline engines. This direct combustion method has a unique advantage. It produces almost zero CO2 emissions. The only significant byproducts are trace amounts of engine oil burned during driving, and some nitrogen oxides due to the intake of oxygen from the air. However, these emissions are considerably lower compared to traditional internal combustion engines. Have you ever considered the performance capabilities of an engine running on hydrogen? The answer lies in the engine's design. Toyota modified its 1.6-liter turbocharged three-cylinder engine, commonly found in models like the GR Yaris and GR Corolla, to accommodate hydrogen fuel. This included the integration of a robust fuel tank for high-pressure hydrogen storage and a re-engineered fuel supply and injection system. Interestingly, hydrogen combustion occurs faster than petrol, offering the potential for a highly responsive engine, a trait particularly beneficial in motorsport applications. But what about the real-world applications of such an engine? Toyota has been proactive in testing and refining this technology in the demanding environment of motorsports. The Corolla Sport race car, equipped with a hydrogen-powered G16E GTS race engine, has demonstrated impressive performance metrics. The rapid combustion rate of hydrogen provides a more responsive race engine experience, proving that hydrogen can be a viable alternative fuel source for high-performance applications. Lastly, what is Toyota's ultimate goal with this technology? It's not just about creating a new type of engine, it's about envisioning a sustainable future. Toyota aims to achieve carbon neutrality by 2050 and sees hydrogen combustion engines as a crucial step in this direction. The company's commitment goes beyond just automotive applications, encompassing collaborations to address challenges in green hydrogen production and infrastructure development. This multifaceted approach underlines Toyota's belief in the potential of hydrogen as a key element in the transition to a carbon-neutral society. So, by combining the familiarity of traditional engine designs with the environmental benefits of hydrogen, Toyota is not just challenging the current EV-centric narrative, but is also redefining what sustainable transportation can look like. Environmental benefits of hydrogen engines. As the automotive world pivots towards sustainable technology, Toyota's hydrogen-powered internal combustion engines present a fascinating proposition. But how exactly do these engines stack up environmentally, especially when compared to hybrid electric vehicles and plug-in hybrid electric vehicles? Let's delve into this question and unravel the environmental benefits of hydrogen engines. Firstly, what makes hydrogen engines stand out in terms of environmental impact? The key factor here is their emission profile. Unlike traditional gasoline engines, which emit a significant amount of carbon dioxide, a greenhouse gas contributing to global warming, Toyota's hydrogen engines produce zero CO2 emissions during operation. The primary emission from these engines is water vapor, making them an incredibly clean alternative in terms of greenhouse gas emissions. But is it really possible to have an engine with such minimal environmental impact? Yes, it is. The secret lies in the combustion process of hydrogen engines. When hydrogen fuel is burned in these engines, it reacts with oxygen from the air to produce energy, with water vapor being the only byproduct. This process starkly contrasts with the combustion of fossil fuels, where carbon in the fuel combines with oxygen to produce CO2. The elimination of CO2 emissions from the tailpipe is a significant step towards reducing the automotive industry's environmental footprint. But how does this compare to HEVs and PHEVs? HEVs, which combine a gasoline engine with an electric motor, and PHEVs, which can be plugged in to charge their batteries, offer improved fuel efficiency and reduced emissions compared to conventional gasoline vehicles. However, they still rely on gasoline and therefore produce CO2 emissions during operation, albeit at lower levels than traditional vehicles. In contrast, hydrogen engines offer the potential for true zero-emission driving, as long as the hydrogen fuel is sourced sustainably. Another environmental aspect to consider is the life cycle emissions of these vehicles. While HEVs and PHEVs have batteries that require rare earth elements and often involve energy-intensive manufacturing processes, hydrogen engines avoid these challenges. The production of hydrogen fuel, especially when derived from renewable sources like wind or solar power, can be less environmentally taxing than battery production, offering a more sustainable overall life cycle. But what about the efficiency of hydrogen engines? The efficiency of a hydrogen combustion engine can be similar to that of a traditional combustion engine, and in some cases, slightly higher. This is particularly relevant in heavy-duty applications, where the efficiency of hydrogen engines can match that of hydrogen fuel cells. The fuel cell, which has a high-efficiency peak at low load, tends to drop in efficiency at high loads. In contrast, hydrogen combustion engines have a peak at high load, making them suitable for applications where high performance is required. As the world grapples with the challenges of climate change and resource depletion, technologies like Toyota's hydrogen engines offer a ray of hope, promising cleaner, greener transportation without compromising on performance or practicality. Performance and user experience. Can a hydrogen-powered engine really match the performance of its gasoline counterparts? Surprisingly, the answer is yes. The key lies in the nature of hydrogen as a fuel. When hydrogen combusts, it does so at a rate significantly faster than gasoline. This rapid combustion translates into a potential for high responsiveness, a crucial factor in performance driving. But how does this rapid combustion impact the overall driving experience? In a conventional ICE vehicle, drivers are accustomed to a certain level of performance, immediate throttle response, a certain growl from the engine, and a feeling of power at their fingertips. The intriguing aspect of HyCEVs is their ability to mimic these characteristics. Despite using a clean fuel source, drivers of Toyota's hydrogen-powered vehicles can still experience the familiar sensations of driving a conventional car. This includes the sound of the engine, which, for many automobile enthusiasts, is an integral part of the driving experience. However, is it possible to harness this performance in a racing scenario? Toyota has put this to the test in the demanding world of motorsports. By fielding a hydrogen-powered vehicle in racing series, Toyota has not only demonstrated the robustness of its technology, but also its potential for high-performance applications. In these high-stress, high-demand environments, HyCEVs have shown that they can stand toe-to-toe with traditional racing cars, offering comparable speed, agility, and endurance. One might wonder, what about the power output? Are hydrogen engines capable of delivering the horsepower and torque that petrol engines do? Toyota's foray into HyCE technology has shown promising results in this regard. By modifying existing engine designs to accommodate hydrogen fuel, Toyota has managed to achieve power outputs that are on par with, and in some instances, surpass conventional petrol engines. This achievement is not just a technical milestone, but also a testament to the potential of hydrogen as a viable alternative fuel for high-performance vehicles. Yet, a lingering question remains. Can these vehicles offer the same level of driving pleasure as their petrol counterparts? This is perhaps the most subjective aspect of HyCEVs, but early indications suggest that they can. Drivers of Toyota's hydrogen-powered vehicles report a driving experience that is both familiar and exhilarating, a combination of traditional ICE vehicle dynamics with the novelty of using a clean, sustainable fuel source. By offering vehicles that retain the performance characteristics of conventional ICE vehicles, Toyota is bridging the gap between the present and the future of automotive technology. Whether it's the daily commute or the adrenaline rush of the racetrack, HyCEVs promise to deliver the performance, sensation, and enjoyment that drivers have grown to love about traditional cars, while simultaneously ushering in a new era of environmentally conscious motoring. Technical aspects of hydrogen engines. Let's focus on one of Toyota's standout achievements in this field, the 1.6L three-cylinder turbo engine used in the Corolla Cross hydrogen prototype. At the heart of this engine lies a blend of traditional design and pioneering technology. But what sets this engine apart from conventional internal combustion engines? The 1.6L three-cylinder turbo engine is a marvel of engineering. It is based on the same platform as the engine found in the GR Yaris, a vehicle known for its performance and agility. However, the adaptation to hydrogen fuel required significant modifications. One of the first questions that arise is, How does Toyota manage to maintain the engine's performance while switching to a completely different fuel source? The key lies in the hydrogen combustion process. Unlike gasoline, hydrogen requires different handling and combustion techniques. The engine employs a high-pressure hydrogen direct injection system, which is a significant departure from traditional fuel injection systems. This system allows for precise control of hydrogen delivery into the combustion chamber, optimizing performance and efficiency. But how does this impact the engine's overall performance? Remarkably, the 1.6L engine manages to deliver power and torque figures that are competitive with its gasoline-fueled counterparts. The turbocharger plays a vital role in this, ensuring that the engine delivers the necessary boost for high performance. But is turbocharging enough to handle the unique properties of hydrogen? The challenge with hydrogen is its low density compared to gasoline. This characteristic necessitates a larger volume of hydrogen to achieve the same energy output as gasoline. Toyota's engineers have tackled this challenge head-on, ensuring that the turbocharger and other engine components are optimized for the unique properties of hydrogen fuel. Another intriguing aspect of the engine is its efficiency. Hydrogen combustion engines can potentially achieve higher efficiencies compared to traditional engines, especially in high-load situations. But what does this mean for fuel economy and environmental impact? The efficiency gains translate into better fuel economy, and more importantly, a significant reduction in emissions. Since the only byproduct of hydrogen combustion is water vapor, the engine achieves near zero emissions, making it an environmentally friendly option. Toyota's approach to carbon neutrality. As Toyota marches towards a future of carbon neutrality, its strategy is not one-dimensional, but rather a diverse amalgamation of both hydrogen and electric technologies. But why would a global automotive leader choose such a multifaceted approach in its quest for carbon neutrality? The first hook in Toyota's strategy is its commitment to hydrogen technology. Why hydrogen, though? The answer lies in its potential as a clean energy source. Hydrogen, when used in fuel cells or in internal combustion engines, emits only water vapor, making it an environmentally friendly alternative to fossil fuels. Toyota's investment in hydrogen technology is not just limited to passenger vehicles. It extends to commercial vehicles and even public transportation solutions. But is hydrogen technology alone enough to achieve carbon neutrality? Recognizing the limitations of a single technology approach, Toyota also embraces electric vehicle technology. The development of battery electric vehicles is a key component of Toyota's strategy. But what sets Toyota's approach apart from other automotive manufacturers that are solely focusing on EVs? Toyota's diversified strategy acknowledges the current challenges in the widespread adoption of EVs, such as the limited range, long charging times, and the environmental impact of battery production and disposal. By offering a range of powertrain options, including hydrogen fuel cell vehicles, plug-in hybrid electric vehicles, and BEVs, Toyota aims to cater to a broader spectrum of customer needs and driving conditions. But how does this diversified approach contribute to the broader goal of carbon neutrality? The answer lies in Toyota's understanding that different regions and markets have varying energy sources, infrastructure, and environmental policies. A one-size-fits-all approach may not be effective in reducing global carbon emissions. For instance, in regions where renewable energy is abundant, BEVs might be the most sustainable option. In areas where hydrogen production can be powered by renewable sources, FCEVs and HYCEs could play a significant role. Moreover, Toyota's commitment to carbon neutrality extends beyond just vehicle emissions. The company is actively involved in initiatives to reduce the carbon footprint of its manufacturing processes, promote recycling and efficient use of resources, and invest in renewable energy projects. But is this enough to achieve the ambitious goal of carbon neutrality? To truly understand the impact of Toyota's strategy, one must look at the bigger picture. The transition to a carbon-neutral society requires changes, not only in vehicle technology, but also in energy production, infrastructure, and consumer behavior. Toyota's multi-technology approach, coupled with its initiatives in other areas of sustainability, represents a comprehensive effort to address these challenges. Challenges and potential of hydrogen engines. As Toyota pioneers the development of hydrogen engines, it ventures into uncharted territory, facing a host of challenges while also unlocking immense potential. But what are these challenges, and how do they impact the journey towards revolutionizing the automotive industry? The first major challenge for hydrogen engines is infrastructure. Currently, the infrastructure for hydrogen fueling is limited, especially when compared to the well-established networks for gasoline and electric vehicle charging. But why is this a significant hurdle? The answer lies in the nature of hydrogen as a fuel. Hydrogen requires specialized storage and distribution systems due to its high flammability and low density. Developing a widespread and accessible hydrogen refueling network is a daunting task, involving significant investment and coordination. However, the potential payoff is immense. A clean, efficient fueling system that could dramatically reduce our reliance on fossil fuels. Another critical challenge is safety. Hydrogen's high flammability makes it a risky fuel to handle. But how is Toyota addressing these safety concerns? The answer lies in rigorous engineering and stringent safety protocols. Toyota has been developing robust containment systems for hydrogen fuel, along with advanced sensor technologies to detect leaks and prevent accidents. However, ensuring public safety extends beyond the vehicles themselves. It involves educating consumers and first responders about handling hydrogen safely, a task that requires time and effort. Despite these challenges, the potential of hydrogen engines to revolutionize the automotive industry is undeniable. But what exactly makes them so promising? The answer is multifaceted. Firstly, hydrogen engines, like the ones Toyota is developing, offer the prospect of zero-emission transportation. In a world grappling with climate change and pollution, this is a significant step towards a cleaner, more sustainable future. Moreover, hydrogen engines can potentially provide a driving experience comparable to traditional internal combustion engines, offering high performance without the environmental guilt. This aspect is crucial in maintaining consumer interest and acceptance, especially among those who are hesitant to switch to electric vehicles due to concerns about range and performance. Toyota's water-powered engine initiative. Toyota's venture into the realm of water-powered engine technology marks a significant leap in the pursuit of sustainable automotive solutions. But what exactly is this water-powered engine initiative, and what are the principles behind this seemingly futuristic technology? Firstly, let's address the core concept, a water-powered engine. The idea of an engine powered by water may sound like something from science fiction, but Toyota is turning it into reality. The fundamental principle behind this technology is the use of water as a fuel source. But how does one extract energy from something as seemingly inert as water? The answer lies in the chemical composition of water. Water, known scientifically as H2O, is made up of two hydrogen atoms, bonded to one oxygen atom. The key to unlocking the energy potential of water lies in separating these hydrogen atoms from the oxygen atom, a process which can be achieved through electrolysis. Electrolysis involves passing an electric current through water to break it down into its constituent elements, hydrogen and oxygen. But what makes hydrogen so special as a fuel source? Hydrogen is a high-energy fuel, and when combusted, it can produce significant amounts of energy. In Toyota's water-powered engine, the hydrogen extracted from water is used as fuel in a combustion process similar to that of traditional gasoline engines. However, unlike gasoline, the combustion of hydrogen produces water vapor as the primary byproduct, resulting in an engine that emits no carbon dioxide or harmful pollutants. This makes Toyota's water-powered engine a highly appealing technology in the context of environmental sustainability. Another intriguing aspect of Toyota's water-powered engine initiative is the filing of patents related to this technology. The patent filings indicate Toyota's commitment to developing and protecting this innovative technology, which suggests a serious investment in making water-powered engines a reality. But how does Toyota plan to integrate this technology into practical automotive applications? The integration of water-powered engines into vehicles presents numerous challenges, including the development of efficient electrolysis systems, safe hydrogen storage solutions, and engine designs that can handle the unique properties of hydrogen combustion. However, Toyota's track record of innovation and technological breakthroughs suggests that these challenges are not insurmountable. Toyota's vision for the future of transportation. As Toyota forges ahead into the future, its vision for transportation is clear: a world where mobility is sustainable, efficient, and in harmony with the environment. But how does this vision align with global environmental goals, and how might it disrupt the electric vehicle industry as we know it today? At the core of Toyota's vision is a commitment to sustainability. The development of hydrogen and water-powered engines is a testament to this commitment. But why focus on these technologies? The answer is simple. They offer a path to drastically reduce greenhouse gas emissions and pollution, addressing some of the most pressing environmental challenges of our time. Hydrogen, as a fuel source, emits only water vapor when burned, making it an incredibly clean alternative to fossil fuels. The water-powered engine concept, still in its nascent stage, promises an even more radical approach to eco-friendly transportation. But is Toyota's vision realistic in the context of the global environmental goals? Absolutely. The Paris Agreement and other international accords emphasize the need to reduce carbon emissions and combat climate change. Toyota's push towards hydrogen and water-powered technologies aligns perfectly with these objectives, offering tangible solutions to achieve these critical goals. Now, let's consider the potential impact on the EV industry. The current landscape of the EV industry is dominated by battery electric vehicles. However, Toyota's hydrogen and water-powered technologies present a new paradigm. But how could these technologies disrupt the existing EV market? The answer lies in the limitations of current EV technology, namely range anxiety and long charging times. Hydrogen vehicles can be refueled quickly, much like traditional gasoline cars, offering a significant advantage over battery EVs in terms of convenience. Furthermore, Toyota's approach diversifies the options available to consumers, challenging the notion that battery EVs are the only path to sustainable transportation. By offering a range of environmentally friendly options, Toyota is not just competing in the EV market, it is expanding the market itself, introducing new concepts that could redefine what it means to drive a sustainable vehicle. By aligning with global environmental goals and challenging the existing paradigms in the EV industry, Toyota is paving the way for a future where transportation is not just about getting from point A to point B, but doing so in a way that is sustainable, efficient, and in harmony with our planet. As these technologies evolve and mature, they hold the potential to disrupt the automotive industry, offering exciting possibilities for the future of mobility. Thanks for watching another episode. Click the next video on your screen for more.